Hello, my lovelies. All right, so we recapped characteristics, and now we have to recap graphing. So I'm going to show you or refresh your memory on how to graph these equations. Technically, we've learned it already through this semester. It's just all coming together at one time. All right, so check out this first set, right? These two right here, they both have a square term. So what is that? That's a quadratic. Quadratic means it's going to be U-shape. If we have a positive number in front, then it's going to be opening up. If it was a negative in front, then it would be opening down. All right, so let me zoom in and focus on this first one. All right, so axis of symmetry, that's going to tell us, right, where to start, right, on our table of values on our calculator. The axis of symmetry formula is negative b divided by 2 times a. All right, so when you look at this equation, the first number is a, the second number is b, and the third number is c. So if I come down here and do the opposite of what's here, so that's negative 12 divided by 2 times a, so 2 times 2. So this is negative 12 divided by 4. Negative 12 divided by 4 is negative 3. So that's going to be the point of symmetry. So the values to the left and the values to the right, it should mirror each other. All right, that's also going to be your vertex, right? This is it. Oh, I guess I should squeeze in. This is an x equals. Your vertex is an x and a y. So we're going to need to figure out what that value is. If you've got these calculators, you're more than welcome to use it. If not, then you could go old school with it, where you plug negative 3 in. So you have 2 times negative 3 squared plus 12 times negative 3 plus 22, and that'll give you the output. Or you could go to the table and you can type this function in, 12x squared. Let's delete that. Oh, just kidding, that's a 2, not a 12. Back it up, Hamilton. All right, so we have 2x squared plus 12x plus 22. Tell it to start at negative 3. And just making sure, yep, so as you go up 2 and you go down 2, you should see that it mirrors each other. All right, so negative 3 comma 4, that's going to be your vertex. And then 2 values above, so let's go this way. You get a 6, negative 5, you get a 12. And then if you arrow down this way, you've got negative 2 and a 6. And negative 1 and a 12. All right, your domain for quadratic functions is all real numbers. You can put anything in for x that your heart desires. The range, however, since this is a parabola opening upwards, we're not going to use all of the y values. All right, when I look at this chart of y values, I don't go any lower than a 4. So my range is going to be greater than or equal to 4. And then the end behavior, this is pointing up on both sides, right? Up on both sides. All right, so then we need to get a quick picture in here. So left 5 up 12. Left 5 up 12. And then left 4 up 6. Left 3 up 4. Whoa, I'm in the wrong spot. Ah! That's what happens when you're on coronication. You lose your mind. Okay, so that should be there. Sorry. And then this should be here. Whoopsie. All right. So then we have negative 2 and 6. And then negative 1 and 12. There we go. All right. So this second one, number 2, is very similar to number 1. You try. And I'll put the answer key on my blog so you can check it. All right, let's jump down to the next type. This is still something squared. All right, so this is still a quadratic equation. That means it's going to be a U shape again. It's in what's called vertex form, so just by looking at it, we'll be able to figure out where that vertex is. All right, so which way does it open? Look at the beginning. Since it's a positive number in the beginning, that's going to be opening up. All right, positive A in the beginning. My axis of symmetry, so let me come back to that. So in parentheses, remember you do the opposite for that transformation. So this is a left 2 and then up 3. So if you go on the graph, left 2 and up 3, that's your vertex, right? Left 2, up 3. All right, so your axis of symmetry goes right through that vertex. So your axis of symmetry is that -2. If I go back to the first problem that we did, I didn't dash that line in, did I? -3, so here we go. So your axis of symmetry, where it folds in half, is along that dotted line. Okay, so back down to it. My domain is all real numbers. My range is going to be anything 3 and above, right? Since it's opening up, it's going to go that way. Our range is greater than or equal to 3, and it's up, up. So the last thing I have to do is to get a picture here. If you want to get some perfect points on your calculator, we go. Edit the function, and we'll type it in. So we have 2, and then x plus 2 squared plus 3. And we'll tell it to start at -2 since that was that vertex. All right, so -1, 5. And then 0, 11. And then it should mirror if I go this way. Yep, so -3, 5. Gee, I love symmetry. -4, 11. But not as much as you see. Have you seen Napoleon Dynamite? The end of the movie, that funny song about technology. All right, so then this next one is a lot like that one, so I'll leave you to it. Ooh, with a quick pointer, this is a negative in front, so it's going to be opening down, right? Okay, flip. So this does not have a square term. It doesn't have a variable as a power. This is linear. All right, so y equals mx plus b is what that is. You want to start at the y-intercept. All right, you want to start here. So we're going to start at -2 on the y-axis. All right, once you're there, then you do your slope. All right, so rise over run. Rise over run. So I'm going to rise 4. 1, 2, 3, 4. And then I'm going to run 3. Ooh, but be careful. Do I run left or do I run right? Because this is negative. So remember, if it's a negative slope, it's got to go this way. So anywho, if I rise 1, 2, 3, 4, I got to go left 1, 2, 3. That way when I connect the points, it shows that decreasing line from left to right. You could also go back to that y-intercept of -2 and go down 4. 1, 2, 3, 4, over 3. 1, 2, 3. Oop, I don't think I went over 3, did I? I didn't. I was confused with my 2. Sorry, 4, 3, so that's over to the 3. All right, so connect the dots, la la la. All right, so let's answer some of these questions. The slope is -4 thirds. The y-intercept is -2. The domain can be any x value that you want, right? Domain is what can you put into the equation. You could use anything you want for x. The range, so what's being used on the y-axis. Remember, I do a little play on words here, and I respell it range. Range. Oh, I forgot my G. Range. Anywho, on the y-axis, this line is going to keep going and going and going. So it's going to use all of these y values to infinity and all of these y values to -infinity. So my end behavior on the left is +infinity. And on the right, it's pointing down to -infinity. All right, so on the left, it's going up, and on the right, it's going down. Okay, so the next one is a lot like it. How about you give it a try, and then you can check the answer key to see how you did. Let me jump down to this one. Ooh. All right, so in order to graph this, you first have to get it solved for y. So I'm going to add 6 to this side. So we have -2y equals -x plus 6, right? When you move it across the equal sign, you just do the opposite. Then here you have -2 times y, so the opposite of times is divide. Everybody gets division. All right, so my equation that we're graphing here is a positive, because negative divided by negative is a positive 1/2 x, and then 6 divided by -2 is -3. So that's the equation you're going to graph right here. All right, before I run out of time on my 15-minute timer, let's jump to the last page. This last page has exponents with variables in them. Ooh, so these are those exponential functions. All right, so exponential functions, your a is going to be your initial value, right? What is it starting with? It starts with a 4. So on the y-axis, that's going to be where we're starting at. Ooh, but just kidding. There is a transformation of +2 here, so let's hold our roll. The b is the base, right? It's changing by a base of 2. The domain, let's see, you can put anything you want in for x, as long as it's a real number. The range is going to be tied to the asymptote. So this is your asymptote right here, 2. Right? So since this is going to be shifted up to ... your range is going to be greater than that 2. We can't touch it. All right? So I made it greater than, not equal to. Since our base is 2, it's growing. If it was a 1/2, then it would be decaying. Then you've got your asymptote at y equals 2. And now I just need some more values to graph. So one way that you could tackle that is by heading on over to that table feature and typing this equation in. Once you're there, you can arrow through and find some values that you want to graph. You notice as you get more and more negative, it just gets closer and closer and closer to 2. Right? It's getting closer and closer to +2. But I'm going to start heading towards the right on some numbers that I can graph perfectly. So -3, 3 is one that I could do. So -3, 3. And then we've got -2, 4. And then we've got -1, 6. Ooh, it's starting to shoot up. And then we've got 0, 10. Boom. And then 1, 18. So there you go. So it's shooting off to space. Come on back down and land gracefully on top of that asymptote. All right. And let's see if I can beat the timer here and do this last problem right here. Our a value is 4. The base is 2. Domain is all real numbers. Since the base is 2, that means we are growing. If you kind of spot check over here, the base of 1/2, that's an example of decay. All right, so this one's growing. The asymptote, so what's being added here? Nothing. All right, nothing's being added here. On this example, we had +2. Here we have plus nothing. So that means our asymptote is greater than 0. So your range is, oops, I put it in the wrong spot, equals, all right, the range and the asymptote go hand in hand. Okay, so let me do my little dotted line at 0 for that asymptote. And then we're going to be crossing the y-axis at 4. And to get some more values, I could head on over to my calculator and edit in this table and see what we can find. Okay, so we've got some fractions, so I'm going to find some nice whole numbers. So -2, 1, and then we have -1, 2, and then we've got 0, 4, 1, 8, 2, 16, starting to blast off there. All right, so here we go. All right, so do me a favor, try the ones that we skipped over, snap a picture of all your hard work, and send it to me on Edmodo, and I'll talk to you tomorrow.